All right, let's pick up again. To remind you again, the challenge of electricity systems is you have to have power consumed equal power supplied all the time, exactly. And we were talking about electricity demand, meaning the use, why we use electricity. And we were talking about examples of the load curve, how it varies by day, how that daily curve varies by location and season, and a few more examples so we can understand demand with a bit more detail. The US state of Florida is a particular interesting case for load variations. It's in the southeast corner of the US, and it's a warm, humid climate. So in the summer, you have peak demand in the afternoon when all the air conditioners are running, space coolers, which makes sense. But in the winter, you have this oddball pattern where there's a lot of electric space heating in Florida, which is rarely used. It's a tropical climate, but there are occasional coldish mornings, 510 C, for example. So everybody turns on their electric space heaters in the morning for just that little boost to keep the house from getting too chilly. And then that goes away. And then there's a little bit of a peak in the early evening, also driven largely by electric space heating. So it gives you some insight into the subtleties of how the load curve, demand curve, varies by location and by season. One more example is how it varies by country. And this shows typical load curves from 2010 for a handful of EU countries. Well, shows the UK, but when the graph was made, that was also an EU country. And notice how, first of all, obviously the larger countries use more electricity, but some of the countries have more seasonal variation. For example, looking at this curve suggests that France has less space cooling than than Germany, for example, because you can see the minimum demand in the height of the summer, but in the winter it's quite a bit higher, implying electric heating is fairly common in France. And you see less seasonal variation in Italy and Spain, surprising because those countries are warmer, but I think probably could be explained in part by perhaps lower penetration of space cooling in Italy and Spain, meaning not all houses have air conditioning. And let's look at a variation within a country. This shows temperature's effects on electricity demand in France. And similar to what we saw in the last graph, the cooler the temperature, the lower the electricity demand. So, I'm sorry, backwards. The warmer the temperature, the lower the demand for electricity. So again, this leads to the conclusion that there's quite a bit of electric space heating in France, because the warmer it is outside, the less you need the heater. Fewer heaters running, less electricity use. And two more comments on demand. Unexpected things can make demand change, and this speaks to the challenges of making electricity systems work. In March 2020, as we all know, the COVID-19 essentially hit globally, though the actual time varied by country, but it was mostly March 2020 when most countries saw very rapid penetration and became aware of the dangers of the COVID-19 virus. And in New York City, US, of course, one of the responses, both of individuals and institutions, was to shut down. A lot of things shut down in New York City in late March as the significance of the crisis became clear. And we saw a fairly significant reduction in electricity demand. Here, we're seeing essentially daily demand over the course of a week, March 2019 and March 2020, showing this significant decrease of about a gigawatt in New York City because of COVID. Let's take a closer look at demand. One more kind of set of demand graphs here. This is for New South Wales, Australia, and it's an attempt to break down demand by what's called end use. What devices in homes, this is largely for homes, are actually driving electricity use. And as you can see, it's a little hard to read some of the colors, but New South Wales has what's called off-peak water heating, when water is heated at times when there isn't a lot of electricity demand. But notice the way those off-peak water heaters, which is the yellowish here, are running. It's in the middle. It's basically after midnight until 4 a.m. They're running, and they're actually making a peak at that time of day. you have a very significant peak at midnight or 1 a.m. due largely to water heating. So you can get a sense of how things change over time. And notice this is again in winter. Well, that's winter for Australia, summer for the Northern Hemisphere. A lot of demand driven, late day demand driven by lighting, because obviously it's darker in the winter. So people are coming home and turning on lights. So that's winter. Let's look at the corresponding graph for summer. Summer in the same area, New South Wales, is driven by air conditioning, but you still see some of this hot water off peak. So it gives you a sense of what are the actual devices driving the demand. Later on in the course, we'll talk about the idea of actually changing demand by changing some of these devices. But for now, the important point is that electricity demand varies for understandable reasons, but it varies over the course of the day, and that curve varies all the time. And the challenge for electricity system that we'll talk about next is, okay, how do you make that electricity? And how do you control or follow the amount of electricity that's demanded? And how do you ensure that the lights never go off? That's what we'll talk about in the next video.